In this section, I want to talk about variable length subnet masking. In previous section, I talked about default subnet masks for each of the address spaces for class A, B, and C. Here, I want to talk about variable length subnet masking. Now, I'm going to give you a scenario. To give you this IP address range, 192.168.10.0/24. Now, they want you to divide these IP addresses into three portions. The first portion has about 110 devices in that. The second portion has about 52 devices. And the third portion has about 30 devices in that. And they tell you that you should not waste your IP addresses. You should be too careful about this and too close to the numbers here. Okay. So how can I do that? First of all, I have 192.168.10.0/24. That means I have the last octet for my host portion. That's because 24 bits are used for my network portion. I cannot touch this. That's it. I only have 8 bits. And for 8 bits, I have 2 to 8, about 256 different combinations. Okay? So I write these combinations here. I want to put crosses here. 2, 3, 4, 5, 6, 7, and this is the 8th one. Okay? Now, they give me these portions, and I want to divide these 8 bits into different portions so that I have 110 devices at minimum in one portion, and second portion I want to have 52, and the third one should contain about 30 devices. So I go to 110 and ask myself, what is the closest exponent of 2 that is of course bigger than 110? We know that 2 to the 7 is bigger than 110, and of course it is about 128. So 128 is the closest exponent of 2 to 110. This gives me the number of bits that I need to assign for my host portion. Okay, so I have 7 bits here. I need, of course, 7 bits here to accommodate about 110 devices. So I go for these 7 bits and I tell that 7 bits, this is the division line here. The right portion is going to be used for host IDs, and I have only 1 bit here for my masking. So I add this 1 bit to this 24 bit. Okay, now I will use a 25-bit address space. Now, what should be the value of this first bit? It can have 2 values, 1 and 0. And I use the smallest one, 0. Okay, so I use 0, and the rest can be anything. And for the rest, I can have a value of 1, 2, 3, 4, 5, 6, 7. So these are the values. If all of them are 1, I will have 127. And if all of them are 0, I will have 0. So the range is between 0 and 127. And because I have taken 0 for this part, for the first bit, this has no value. So the range is again between 0 and 127. So how can I write these IP addresses here? I write this. The starting IP address is going to be 192.168.10, and for the bit mask I have 0 here, so I cannot assign anything. This is off, so this is going to be 0/25, and the /25 gives me these IP address range. I have 192.168.10.0 to 192.168.10.127. And of course, you know that this is the first value, it is network ID. This is the last value, this is broadcast ID. So the useful range is going to be 192.160.10.1 to 192.160.10.126. This is the first portion. So, you know that I used value 0 for the first bit, so this cannot be 0 any longer because I have used all of it. The only value remaining is 1, so let's go for the second portion. They gave me 52 devices in this portion, and I want to assign enough IP addresses out of this range that have been given. So the first bit, I write the 8 bits again. 1, 2, 3, 4, 5, 6, 7, 8. And we know that the first bit cannot be 0. So I need to write 1 for the first bit. So again, I ask myself, what is the closest component exponent of 2 to 52? Of course, it should be bigger than 52. I know that 2 to the power of 6 is about 64. Okay, the 64 is bigger than 52. That's okay for me. And this gives me the number of bits that I need to assign for the host ID portion. So 6 bits, I need to, draw the line here. 2 bits to the left and 6 bits to the right. 6 bits to the right for the host portion and 2 bits to the left. So I have 2 values here, 1, 0 and 1, 1. This cannot be 0, as I told you, but this one can be 1 or 0. But again, I need to, select the smallest one. So I write 1, 0, and the rest can be anything. And this gives me the value of, this has a value of 128. The second has a value of 64 and it cannot be assigned. That's because it's 0, it is off. So 128 is the starting number and the finishing number is 192. That's because if all of these are 1s, and of course it is going to be 191. Sorry for the inconvenience. If add the value of these, this is 1, 2, 4, 8, 16, and 34. Get a 61 and 61, and this has a value of 128. So at maximum, it is going to be 191. Again, as I told you, these two are for the masked portion. So if I want to write this, I need to write 192, 168, 10. And for the masked portion, as you know, I have 128 and this is 0, so it gives me 128 slash 26 because I have 24. And I have 2 bits here. I'm adding these 2 bits to the 24 bits, so I get a 26-bit mask. That's it. The starting IP address is going to be 192.168.10.128, and it ends with 192.168.10.191. And you know that this first one is my subnet ID or network ID, and this last one is my broadcast ID. So the starting range that has useful IP addresses is 129, and the end IP address is going to be 190. So let's go for the third portion. I have 30 devices here, so I need to find the closest exponent of 2 that is of course bigger than 30. So this gives me 5 bits, so I have 32 addresses in here. So let me write down the bits again here. I have 8 bits. 5, 6, 7, 8. And I know that the first bit should be 1. The second bit cannot be 0. This is because I have used all of the addresses in this range. So it should only be 1. And the rest can be anything. So it gives me this. The first bit is 128. The second bit is 64. I will have at least 192, and we have 1, 2, 4, 8, 16, and 32. So at maximum, we will have about no, we need 5 bits actually. We need 5 bits. I'm sorry for this. So this is the division line. I need to draw this here. This can be 0 and 1. If I want to write this down, if I take the smallest one, this is 0. I take this, so it is going to be 1, 1, 0. For here, I have 1, 2, 4, 8, 16. If all of these bits are 1s, so the highest number is 31. We have a 64 here, and we have a 128 here. So it's going to be 223. 223. So this is the range that I have here. So if I want to write all of those IP addresses again, I need to write 110. And of course, I have another range that is going to be 111. So I have, of course, 2 different portions. And it is going to be 192, 168, 10, 192/27, because 3 bits have been added to the 24 bits mask. And for the second portion, because this has a value of 32, it is going to be 192, 168, 10, 224/27. And of course, I don't need these. They have only one portion that has 30 IP addresses in that. So these are the ranges that I have. Let me write it down again. I have 192, 168, 10, 0/25 for the first portion, 192, 168, 10, 128/26 for the second portion, and I have 192, 168, 10, 192/27. Oh my god, let me clear this. 192/27 for the third portion. So in next section, I want to give you another example. I want to give you another example so that you are quite comfortable with what I am doing here.